Hello there, we're going to do some Year 12 further math statistics here. We've got exercise 1C. Now this is looking at combinations. Sometimes combinations are referred to as selections, so it's worth looking out for this word as well. Sometimes how many different ways can you select 3 out of, say, 10 people? Or well, in this case actually it says we've got 5 people we're inviting to dinner. And it looks like we've got a teacher, a nurse, an artist, magician and Superman. I think most people would invite Superman first, wouldn't they? But assuming you pick these randomly, the only problem we've got is we've only got 3 chairs. So presumably 2 people are going to be left standing, perhaps eating their meal while standing up, and 3 people are allowed to sit down. So how would you decide who got the chairs? That's basically the question here. And just be aware that if you sat the artist, the magician and Superman down in that order, and then alternatively thought, well, I could move them around, we could have the Superman, then the artist and the magician. Well, in terms of combinations, which is what I'm looking at today, these 2 different orderings are actually, we count them as being the same combinations. So the artist, the magician, the Superman, that's one combination. Another one might be, for instance, number 2 might be, we'll say the teacher. We'll definitely have the teacher as me. We'll have the Superman. And we'll have the nurse. So those 3 would be a different combination. You can see that the people who are allowed to sit down are different to the ones up here. And I suppose the big question is, how many would you get? And we can perhaps answer that in a bit. You could even try and list them all out. I'm just going to do a little cheat on my calculator. There are many. There's only 10. There's 10 different things you could do. Now, the mere fact that I've just gone to my calculator there tells you there's a button on the calculator. I actually might as well tell you, the button I used was NCR. It's actually above the divide button. So if you look at the divide key on your Casio calculator, it says NCR just above it. And I literally typed into my screen 5, because I've got 5 people I'm asking to dinner. How many different ways can I choose which 3 are going to get the chairs? And when I did that, I got 10. So a little starter for us before we go on to using that button more generally. How many different, again, we've got this idea, we want different 7-digit numbers can be formed from the digits 0, 1, 2, 2, 3, 3, 3. Assuming that the numbers can start with 0. Now just a reminder, if we had all the digits were different. So imagine I said 1, 2, 3, 4, 5, picked 8, 9. 1, 2, 3, 4, 5, 6. I've got 7 numbers in total. If I was to arrange those, it would simply be 7 factorial. You might recall that. You might recall as well that when we was doing words and stuff on a previous example, if it was 1, 2, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yeah, but it would still be 7 factorial. But because I've got 2 that have been repeated, you divide by 2 factorial. So just be aware that that maths that we use in the past with letters effectively still applies with numbers. It doesn't really matter that they're numbers now. The only issue is they can't start with a 0. And I think it kind of will matter whether or not I start with other numbers. So for instance, I could start, make one up. I could start and I get 1, 2, 3, 0, 3, 3, 2. That would be one possible number. But I could instead, for instance, start with a 2. And that would be like, 2, 1, 0, 3, 3, 2. And what am I missing? A 3. 1, 2, 3, 4, 5, 6. Or I could, I suppose, start with a 3. That's a 3, 3, 0, 1, 2, 2, 3. So that's possible options. And I think it matters which one I start with, because what's left then determines how it goes on. So by that I mean, if I start with a 1, I think I've got 6 letters, 6 numbers rather, 6 factorial. And of those, if I start with a 1, I've got 2 2s left. So I'd have to divide by 2 factorial. And I've got 3 3s, so I divide by 3 factorial. And I've only got the 1 0, so that's okay. So if I type that in, 6 factorial divided by 2 factorial divided by 3 factorial, I get 60. See if you can do that on your calculator. when you get 2's at the front, what's that? This was this one. So if I've got a 2 as my start number, well, I've still got 6 numbers left, 6 factorial. Now if I've got a 2, can you see that effectively there's only 1 2 left? That matters. So if I've already used my 2, I've got to divide by the fact that I've got 3 factorial for the 3's, but the 0 and the 1, they're fine. So 6 factorial divided by 3 factorial, I get 120. And the last possibility is I start with a 3. If I start with a 3, well, just thinking about it, if I start with a 3, there are only 2 3's left. Because there were 3 and now I've started one, there's only 2. But there are 2 2's. So I think in this case I'll do 6 factorial divided by 2 factorial divided by 2 factorial. And when I did that, I got 180. So in total, 60, 180, I reckon 360. There are 360 different ways. You can see why I didn't want you to list them. It would take you forever. How many of these would end in a 0? All right. So if I end in a 0, just think about it. Again, if I start with a 1 and then end in a 0, so that is like a 1 dot 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 then a 0. So if I do that, the 1's gone, the 0's gone. There are only 5 numbers left, so 5 factorial. And I would still have all my 2's and all my 3's. I think it's divided by 2 factorial divided by 3 factorial. But if I start with a 2 and end in a 0, I think it's 5 factorial divided by, well, just the 3 factorial, because there's no possibility of me having 2 2's. And if I start with a 3 and end in a 0, then it's still 5 factorial. I think it's 2 factorial, 2 factorial. Look, I think the bottoms are always the same. Now, I don't know what these are. 5 factorial divided by 2 factorial divided by 3 factorial. I get 10 for that. This one, by definition, therefore, must be 20, because I haven't divided by the 2 factorial. And this last one, 5 factorial divided by 2 factorial twice, I get 30. And if you add those up, I get 60. Now, there might be other ways of doing that, but that's where I thought of doing it. Notice how particular I've been to try and work those out. 360 and 60. Now, this is the button I was referring to. There's a formula that goes with it as well. I try not to use the formula if I possibly can, but you'll notice the number of ways of selecting R things from N things, sometimes with this funny notation like a bracket, like a matrix, is n factorial divided by n minus r factorial, r factorial. Best way of showing you this is to do an example. So I've got 10 things and I want 3 of them. So that's obviously 10C3. And I'm going to write that as 10 factorial divided by, now 10 minus 3 factorial is 7 factorial. So you notice I get that on the bottom, but I also get the 3 factorial as well. If I do that, I get 10 factorial divided by 7 factorial divided by 3 factorial. 120. Now there's a quicker way of doing it. There it is, 120. Use a calculator. Okay, just type in using this button there. Combinations then, a real life question, I suppose. A football manager has a squad of 16 players. He needs to choose 11 players to start the match. How many teams could he, different teams could he choose? Now this assumes that any player can play any position, which is probably not true. But basically I've got 16 things. I want 11 of them. 16C11. That should be it. 16C11. 4,368 I get. 4368. What's the answer? 4368. That's it. Notice the different notation I use there. Just get used to this. Sometimes it appears in exams. I personally never write it like that. Example. In how many different ways can a committee of 5 people, we want 5 people from all the people around this table then. Notice there are 3 men and 7 women. Now, if there are no restrictions on the committee, so I've got 10 in total, so for part 1 you just go 10C, I want 3 of them. No restrictions whatsoever, so 10, just give me 3 people on my committee Oh no, I don't want 3 people, I want 5 people. And you go, well, it says there I want 5 people on my committee. So 10C5 I'm typing in, and I've got 252. So if I don't care who's on the committee, there's 252 ways I can pick that committee. 2. What if it says it must contain 2 men and 3 women? Now notice where I do this. 2 men. Now there were 3 men. I want 2 of them. So I have to say of the 3 men, I need to choose 2 of them. 3C2. And whenever it's and, you times by of the 7 women, I need 3 of them. So 7C3. It's restricted. I'm going to get 2 men and 3 women. So 3C2 times 7C3 equals 105. It's a standard way of doing these questions. Next question says must contain at least 1 man. Now I'm tempted to think, it might be easier to assume there were no men. That's a 3, part 3. If I did this, I could basically say, I know there's 252 ways of doing it altogether. How many of those would have no men? So if I had no men, basically none of these 3 would be chosen. I've got to choose them all for my 7. So I'm going to do 7C5. So 7C5 would be 7C5. 21. There are 21 ways of picking 5 from 7. So that means of the 252, 21 ways won't give me a bloke. So I reckon 252 minus the 21 will give me a man. So that's 231, I think, if my maths has served me well. Let's just check the answers. 231, yeah, 105 and 252. Those answers are all correct. Well, this is the last example. 5 cards are dealt without replacement from a standard pack of 52 cards. You might need to know about cards in these questions. So just a little reminder. You get 4 suits when you're playing cards. They are hearts, diamonds, clubs and spades. These 2 are both red. These are both black. Each suit has 13 cards. The cards are basically, they go from 1 all the way up to 10, followed by a jack, a queen and a king. Slight confusion is that the 1 is usually called an ace. The 1 is the ace. An ace can be thought of as being a high card. So that can sometimes go up there. The jack, queen, king are sometimes called picture cards. Or face cards even, so because they've always got a face on them. So let's try and do the question. 5 cards are dealt without replacement. That means they don't get put back in. How many different ways could the cards be dealt? Well, I've got 52 cards in the pack. I want to choose 5 of them, so 52C5. 52C5. 259. Notice I'm trying my best not to use that horrible formula at all here. 2598960. There we go. In how many ways could there be 5 cards contain 3 hearts? Okay, well that means of the 13 hearts, 13, I need to choose 3 of them. And of the 39, 3 13s are 39, remember they're 4 suits, 13 each. Can only therefore, there's 5 cards I'm choosing, I can only choose 2 of them. I times the answers together. 13C3 times 39C2. The great thing about this calculator button is it does all the work for you. If you had to work out all the different combinations yourself, it would take you a long time, particularly when there's 211,000 of them. My answers, according to me, are right. So look, we could have put another 10 different types of questions. One of the issues we have with this kind of counting different ways of combinations is there are lots and lots of different types of questions we can be asked. We're going to try and do a range of questions. The questions in the textbook will presumably give us more examples, and hopefully eventually we've done enough examples. But be warned, we can get confused on these. They can be quite tricky.